Units of measurement. Units refer to a quantity of a constant magnitude used to measure the magnitudes of other quantities of an identical type. So in simple words, units are defined as the reference standard used for measurement. So here we have some units written down here. For example, for mass we have grams, milligrams, kilograms, and etc. So these are the units that are basically standardized to measure a specific quantity of mass. So now let's look at this SI system of units. The International System of Units, also called SI, is a standardized system of measurement used in science, industry, and commerce around the world. The SI system is based on the metric system and provides a universal and consistent system of measurement for physical quantities. In the SI system, there are two types of units: the base units and the derived units. So here we have a table of some basic physical quantities and their base units. Base units are the fundamental units of measurement in a system of units. These units are used to define and measure physical quantities. So there are total 7 base units, which I have all written down over here in this table. First we have mass, which has a base unit kilogram. The symbol of this unit is kg. Length has a base unit meters, symbol m. Time measured in seconds, symbol S. Temperature measured in Kelvin, symbol capital K. Electric current measured in amperes, symbol capital A. Pressure is measured in atmospheres, which has a symbol pascals. Amount of substance is measured in mole, symbol mole. Luminous intensity is measured in candela, which has a symbol CD. Now, these base units are important to remember as they are the fundamental units of measurement in a system of units. These are the units that basically are used to define and measure physical quantities. And from these base units, we get the derived units, which are the second types of units in the SI system. So derived units are units of measurement that are formed by combining 2 or more base units. These units are used to measure physical quantities that cannot be expressed in terms of a single base unit. And here is a table of some physical quantities and their derived units. So basically, derived units are units which are used to measure physical quantities that cannot be expressed in terms of a single base unit. It's not necessary that a derived unit is supposed to be made of only base units. It can be made up of derived units as well. For example, density is made up of gram per centimeter cube. So centimeter cube is a derived unit of volume, and grams is a base unit of mass. Now let's read some of the physical quantities and their derived units in this table. Now there are many different physical quantities with their derived units. I've just written down a few of them here. Firstly, we have volume, which is measured in centimeter cube. The symbol of this derived unit is cm with a small 3 above. Overall, we read it as centimeter cube. Now this derived unit is made up of 3 base units. Okay, so for example, I have a cube here and I want to measure the volume of this cube. So I would basically measure the width, height, and length of this cube, all in centimeters, and multiply all of them to get an answer in centimeter cube. So when we multiply 3 centimeters, we get a centimeter cube. So basically, centimeters multiplied by another centimeter and another centimeter are 3 base units multiplying to form a single derived unit. So volume was an example of a derived unit. Then we have density, which has a derived unit gram per centimeter cube, symbol G/cm cube. Now this derived unit is made up of one derived unit and a base unit. Grams is a base unit of mass, but centimeter cube is a derived unit of volume. So for example, if I want to find the density of this cube over here, I would divide the mass of this cube with the volume of this cube to find the density. So basically what I'm doing is dividing grams with centimeter cube and so I get a derived unit which is gram per centimeter cube. So this was density. Then we have velocity, which has a derived unit meter per second. Now this derived unit is made up of base units only, two base units. One is meter and the other is second. One is the base unit of time and the other is the base unit of length. Then we have acceleration, meter per second square. And lastly we have force, which is measured in newtons, symbol capital N. Now make sure you don't confuse this newton with base units, as it is not a base unit. It looks like one, but actually the derived unit of force is too long to write down. So they have shortened it down to Newton, who was a scientist who discovered force. So Newton is not a base unit, it is a derived unit. Now that we've understood base units and derived units both, as well as the SI system of units, we can move ahead onto the metric system of units. So, the metric system is a system of units for measuring length, mass, volume, and other physical quantities. The metric system is based on the decimal system with units that are related to each other in multiples of 10. The metric system also includes prefixes that indicate multiples or fractions of the base units. Now let's understand what we're trying to talk about here. To understand the metric system of units, we have to understand prefixes. So what are prefixes? Prefixes in units are used to indicate multiples or fractions of the base unit of measurement. So in the metric system, prefixes are added to the base units to indicate larger or smaller quantities. So here are some common metric prefixes and their meanings. Prefixes are basically added to the base units to indicate smaller quantities or larger quantities. So we have a base unit, meter for example. If I want to make this meter 1,000 times bigger, then rather than writing 1,000 meters, I would simply write 1 kilometer. Because what kilo means is 1,000 times the base unit. So I basically put this prefix behind the base unit, meter, and I get kilometer, which means 1,000 times the base unit. In other words, 1 meter multiplied by 1,000 is 1 kilometer. So adding this prefix made the base unit bigger. In the same way, we can make a base unit smaller using these three prefixes. Milli, for example, if I put this prefix, it would mean 1,000th of the base unit. What 1,000th of the base unit means is that if I divide 1 meter into 1,000 parts, that 1,000th part of the meter would be called a millimeter. If I say milligrams, I'm basically dividing a gram into 1,000 parts, and that 1,000th part is going to be a milligram. In the same way, we have micrometer, which means 1,000,000th of the base unit. In other words, if I divide a meter or any base unit into 1,000,000 parts, that one part would be called a micrometer. Nano means 1/1000th of the base unit. Mega means 1,000,000 times the base unit multiplied by 1,000,000. And giga means 1 billion times the base unit multiplied by 1 billion. So these were the common metric prefixes and their meanings. Now we're going to understand the conversion of units. Basically, how can we convert a specific unit into a different unit? For example, kilo into milli. If I want to convert kilograms into milligrams, how would I do that? Now this conversion of units helps us in different cases. For example, if I'm baking a cake and the recipe I'm given is in pounds, but the scale I have to measure the ingredients of the cake shows me the measurement in grams, then I would need to convert the recipe of pounds into grams in order to make it. So in this case, I would have to convert pounds into grams. So conversion of units refers to the process of changing a quantity expressed in one unit of measurement into an equivalent quantity expressed in another unit of measurement. And this is typically done by multiplying or dividing the original value by a conversion factor, which is a ratio that expresses the relationship between the two units. And here we have a table of some conversion factors: length, time, and mass. So let's read them out. 1 kilometer is a unit of length. and this kilometer is equal to 1000 meters. This we have known before as well, because kilo is a prefix which is equal to 1000 times the base unit, and 1 meter is equal to 1000 millimeters. So the conversion factor is that 1 kilometer is equal to 1000 meters and 1 meter is equal to 1000 millimeters. So if I'm going to convert a kilometer into meters, then I would use this conversion factor, which is that 1 kilometer is equal to 1000 meters. Say for example, I have 50 kilometers here and I want to convert it into meters. So what I would simply do is multiply or divide the original value by the conversion factor. Now the rule for conversion is that if it is a big unit than the unit we are going to convert it into, then we would multiply the original value with the conversion factor. But if it is a smaller unit than the unit we are going to convert it into, then we divide the original value by the conversion factor. So if we are converting meters into kilometers, then I would divide. But if I am converting kilometers into meters, then I would multiply. So what I would do is multiply 50 by 1000 in order to get the answer, because the conversion factor is 1000. 1 kilometer is equal to 1000 meters. So if I'm converting a kilometer into meters, I would simply multiply 50 by 1000 and what I get is 50,000 meters. Okay, in the same way, if we are converting meters into millimeters, then we would again multiply the original value in meters by 1000, because the conversion factor is 1 meter is equal to 1000 millimeters. So I would multiply the original value by 1000 in order to get the answer in millimeters. But now say for example, I want to convert 50 kilometers into millimeters. Then what I'm going to do? If we are converting a base unit into a different unit, then it's very simple. We just multiply or divide with the conversion factor. But if we are converting a given unit which is not a base unit into a different kind of unit which is also not a base unit, then what we do is that there are two stages involved in this type of conversion. The first stage is to convert the given value in kilometers into meters. First into meters. This is the first stage. When we convert the kilometers into meters, then we convert the meters into millimeters. So this is the difference between converting base units into a given value or given value into its base unit, or converting a different kind of unit into again a different unit, not a base unit. So for that, we first convert whatever the original value is, we convert it back into its base unit first, and then convert the base unit into the desired unit. So say for example, I have 50 kilometers and I want to convert it into millimeters. So I first convert the kilometers, 50 kilometers into meters. So 50 kilometers into meters is how much? We just took it out just a minute ago. It is 50,000 meters. Now I would convert this meters into millimeters. And for doing that, I again apply the conversion factor, which is 1000 millimeters is equal to 1 meter. So I would again multiply 50,000 meters with 1000 in order to find the answer in millimeters. So 50,000 multiplied by 1000 is 50 million millimeters. So how do we write it? 50, comma, 3 zeros, comma, and 3 zeros again. Now that's a big answer. Of course, if we convert 50 kilometers into millimeters, then it would be a big answer because millimeters is very small. Now we can see that 50 kilometers are equal to 50 million millimeters. In the same way, if we are converting kilometers into micrometers, we first convert the kilometers into meters this way, and then convert the meters into micrometers. What is the conversion factor for micrometer? This is the conversion factor. 1 million micrometers are equal to 1 meter. So then what we do is multiply again, because we are converting a bigger unit into a smaller one. So we multiply 50,000 by 1 million to find the answer in micrometers. Now say for example, I have millimeters here and I want to convert these millimeters into micrometer. Then again, because I'm not converting it into a base unit or a base unit into a desired unit, so I have two different types of units. Millimeters into micrometers. None of them is the base unit. So if I'm converting millimeters into micrometers, I would first need to convert millimeters into meters and then convert the meters into micrometer. Now, the conversion factor of millimeters and meter is 1000. 1 meter is equal to 1000 millimeters. So I would multiply. No. I would divide the millimeters by 1000 to get the answer in meters, because millimeter is smaller than the meter. So it's a smaller unit compared to the meter. So for converting smaller units into bigger ones, we divide. So I would divide 50 by 1000 to find the answer in meters first. And my answer is 0.05 meters. So 50 millimeters are equal to 0.05 meters. Now I'm going to convert these meters into micrometers. So the conversion factor for meters and micrometers is that 1 million micrometers are equal to 1 meter. Now, because I'm converting a bigger unit into a smaller one, I would multiply. Before, millimeters was smaller than meters, so I divided. But now meters is bigger than micrometers, so I'm going to multiply. So 0.05 multiplied by 1 million is equal to 50,000 micrometers. So this is how we converted millimeters into micrometers. So it's just so simple. We have to just multiply with the conversion factor. Multiply or divide with the conversion factor. But if I'm converting the given unit into a smaller unit, smaller than the given unit, then I would multiply. And if I'm converting a small unit into a bigger one, then I would divide. So I have a conversion that doesn't involve base units at all. Say for example, millimeters into micrometers is a conversion, or kilometers into millimeters, or kilometers into micrometers. There are a lot of pairs we can make which doesn't involve the base unit. Then I would simply do the conversion in 2 steps. The first step is to convert the given unit into its base unit first, and the second step is to convert that base unit into the desired unit. So there are 2 stages involved in this. So for conversion, we have to remember the base units as well. So we have to remember the base unit of time in order to convert a unit into a different unit. So if I'm converting minutes into hours, I should know the base unit, because I would first have to convert minute into the base unit and then convert the base unit into hours. So minute is not the base unit. Neither is hour the base unit of time. The base unit of time is the second. So for converting a minute into an hour, I would first have to convert the minute into seconds and then convert the seconds into hours, just in 2 steps. But if I'm converting a minute into seconds or an hour into seconds, then I would simply just put the conversion factor and do it. There's no 2 steps. In the same way of mass, for example, I'm converting kilograms into milligrams. For that, I would first have to convert the kilograms into grams. Okay, this is kind of confusing because the base unit of mass is not grams, it is kilograms. So this kind of can get confusing, but in conversion, we take gram as the base unit of mass. But when we read the base units, the base unit of mass is the kilograms. So you should just remember that in conversion, the base unit of mass apparently is grams. But in actual, kilograms is the base unit of mass. These are certain things that we have to just memorize to make it simple. So this is what conversion is.